this model, we see the moon orbiting the Earth in a flat circular orbit. The orbital path of the moon is highlighted in light blue. For demonstration reasons, the orbital distances have been drastically reduced, and the Sun has been scaled down to 10 times its normal size. Lunar eclipses occur when the moon passes behind the Earth, crossing through the Earth's shadow. Solar eclipses occur when the moon passes between the Earth and the Sun, casting a shadow on the Earth. Here we see the moon's shadow travel across the surface of the Earth. Every time all three bodies align, we see an eclipse occur. This alignment is known as syzygy. Under these conditions, an eclipse would happen twice every 29.5 days. Once when the moon passes between the Sun and Earth, then again 14 days later when the moon passes behind the Earth. Solar eclipses can only occur when the moon is in the new moon phase, and lunar eclipses can only occur during the full moon phase. We see that no matter where the Sun is in respect to the Earth and moon, eclipses will occur. But this model is not realistic. The orbital path of the moon is not flat. In reality, the moon orbits the Earth at an inclination of just over 5 degrees. So let's tilt the moon's orbital plane for more realism, and we'll begin to see exactly how this affects why eclipses occur. In this demonstration, the moon and Earth are to scale, but since the moon is at 1/10 its average distance from the Earth, we will have to give it a 15-degree tilt for the desired effect. Now that the moon's orbit has been adjusted, let's add a little more realism to our model. If we scale the Sun to normal size at this range, it would consume the Earth and moon. So we'll move it to its average 93 million mile distance while enlarging it to full size. The full moon phase occurs when the moon is aligned behind the Earth in respect to the Sun. The illuminated side of the moon is visible to the nighttime side of the Earth, and we see no eclipse has occurred as the moon is at its highest orbital point and out of the path of the Earth's shadow. New moons occur when the moon is in alignment between the Sun and Earth, when the dark side of the moon is exposed to the daytime side of the Earth. But we see again that no eclipse occurs due to the moon being at its lowest orbital point. This time the moon is too low to cast its shadow on the Earth. Only when the moon is level with the Earth and Sun can eclipses occur. To further understand eclipses, we have to look at what is known as the ecliptic plane. The ecliptic plane is an imaginary plane that is stretched between the center of the Sun and the center of the Earth, shown here in purple with a blue grid for motion reference. The 2 points where the moon passes through this plane are known as ecliptic nodes and are the key points in understanding the mechanics of an eclipse. Here we see the moon as it passes through the descending node located here on its voyage to its lowest orbital point. Then again here, passing through the ascending node on its way to its highest orbital point. This cycle repeats every 27 days on average. We see that the moon is level level with the plane of the Earth and Sun at these two locations. These nodes are the orbital positions the Moon must be in for an eclipse to occur, but only when they coincide with the new or full moon phases. To understand where the ecliptic nodes coincide with these locations, we have to zoom out and study the Earth as it travels around the Sun. Eclipse seasons happen every 173 days on average. To see when this occurs and how, let's look at the Earth and Moon as they orbit the Sun. The Moon's orbital plane is highlighted in blue. The orbital plane of the Moon apparently stays oriented in a fixed direction. We see that full and new moons are occurring with clockwork regularity. Also, we see the Moon passing through the ecliptic plane twice with every revolution. The green line represents where the Moon aligns with the Earth and Sun during new and full moons. As the Earth makes its way around the Sun, we see the ecliptic nodes start to align with the new and full moon locations. This time of alignment is known as the eclipse season, and the orbital location in which it occurs is shown in red. The eclipse season can last 31 to 38 days. At least 2 eclipses will occur during this time. As the nodes move out of alignment, the season expires. The tilted orbital plane of the Moon, although apparently fixed, actually rotates slowly in the same direction as the orbit of the Moon. This is known as precessing and takes 18.6 years to complete one revolution. As the Earth travels around to the other side of the Sun, we see the cycle begin again. We see the Moon pass through the Earth's shadow, and then the Moon's shadow pass across the Earth's southern hemisphere. A third eclipse may occur, but as we see, it is toward the end of the season and will be a partial eclipse as the nodes are again moving out of alignment. The 31 to 38 day variation in the eclipse season is due to changes in the Moon's orbital speed and changes that occur to the shape of the Moon's orbit. There are several forces that factor into these events.